Now we're going to be looking at how to apply the concept of inverse of a matrix to solve simultaneous equations. So now let's consider this simultaneous equation in which we have 2x plus 3y equals to minus 5 as my first equation, and I have x minus 4y is equals to 14 as my second equation. So now I can write this in matrix form as, so I bring out the coefficients here, which are what, 2, 3, 1 and minus 4. Then I multiply by the unknowns, which are x and y, is equals to the results are minus 5 and 14. So I can write this as AW is equals to Z, where A represents this matrix over here, W represents the unknown, and Z represents the results. So if I make W the subset of formula W, which is the unknown, I have my W being equals to the inverse of A, similar as 1 over A, times Z. So to find the unknowns, I need to multiply the inverse of A by Z. So let's see what this is all about in practical terms by solving that example. So here we know that what AW is equals to Z. So we know that W, or the unknown, is equals to what, the inverse of A times Z. So we need to find the inverse of A. If you recall, the inverse of A is given as what, 1 over the determinant of A times the adjoint of A. Now the determinant can easily be computed, so the determinant of A will just be equals to what, minus 4 times 2, which gives me minus 8, then 3 times 1, which gives me minus 3, and that is equals to what, minus 11. Now the adjoint of A will just be equals to, I will need to change this first diagonal, so I have minus 4 and 2 over here, but I will leave the other diagonal as it is, but I change the polarity, so I just include the minus. So this is the adjoint of A. So the inverse of A will just be equals to what, 1 over the determinant, which is 1 over minus 11, times the adjoint of A, which is minus 4, minus 3, minus 1 and 2. So now I can bring this out and multiply this scalar quantity minus 1 over 11 by all the elements that are in within here. So I have my inverse of A being equals to, when I do that, I have minus 1 over 11 times minus 4, which gives me 4 over 11. Here I have minus 1 over 11 times minus 3, which gives me 3 over 11. Here I have minus 1 over 11 times minus 1, which gives me 1 over 11. And I have minus 1 over 11 times 2, which gives me minus 2 over 11. So now I can find the value of W. So I know that W is equals to what, the inverse of A times Z. And I found the inverse of A to be this. So the inverse of A here is what, 4 over 11, 3 over 11, 1 over 11, minus 2 over 11, then times the value of my Z is what, minus 5 and 14. Now if you look at this, this is a 2 by 2 matrix, and while this is a 2 by 1 matrix, you have 2 rows and 1 column. And for multiplication of matrix to occur, the number of columns in the first matrix must be equal to the number of rows in the second matrix. So here we have 2 columns and here we have 2 rows, so we can multiply these two. And what will the product be? The product will be, you take the number of rows in the first column in the first matrix and number of columns in the second matrix. So the product of these two matrix is going to be what, a 2 by 1 matrix. So I'm going to have 2 rows and 1 column. So let's start out. Let's try to multiply this together. So what would that become? So first off, I have to multiply the first row by the first column. I add the first by the first column to get the first cell here. So I have 4 over 11 times minus 5, then plus 3 over 11 times 14. And for the second row now, I need to multiply the second row by the column. So here I have 1 over 11 times minus 5 plus minus 2 over 11 times 14. And when I solve that, what would that become? That becomes, my W becomes what? Minus 5 times 4 gives me what? Minus 20 over 11. Then plus 3 times 14 gives me 42 over 11. Here I'm left with what? Minus 5 over 11, and minus 2 times 14 gives me minus 28 over 11. So when I add this together, this becomes what? Minus 20 plus 42 gives me what? 22 over 11. And while here I have minus 5 minus 20, which gives me minus 33 over 11. So I can see that what? My W, which is the same thing as what? Value of x and y is equals to what? What is 22 divided by 11? 2. And what is minus 33 over 11? Minus 3. And if you recall, for two matrices to be equal, then the corresponding cell will be equal. So if we compare the cells together, we can see that what? X is equals to 2 and y is equals to minus 3. So the value of x is 2 and the value of y is minus 3. So to recap, to solve simultaneous equation, in this case which is W, we multiply the inverse of A by Z. So we know how to find the inverse of A, and that is what we did here, and we got the inverse of A to be this. So we multiplied it by Z, which is minus 5 and 14. And when we did that and we simplified, we got our value of x to be 2 and our value of y to be minus 3. So this pretty much sums up how to apply the concept of inverse of matrix to solve simultaneous equations.